Hello everyone, Thiago speaking again. Today I'm going to talk about cones, okay? Some students of mine requested me to remember some basic concepts about cones, so I decided, spatial geometry, so I decided to come up with an exercise, okay? And solve this exercise, and during the resolution of the exercise to remember some basic concepts, and also to make it easier for you to understand these concepts regarding cones, okay? So, first of all, before I forget, subscribe to the channel, give your like at the end if you do like, right? And don't forget to put in the comments what is the next kind of exercise you want me to solve here, or what did you think about this video, anything. Your opinion is always very valuable for everything you do and for our work, okay? So let's show the problem, okay? I have here it's the same problem basically in Portuguese and English. So let's read here. A piece of cardboard has the shape of a semicircle of radius 20 centimeters. With this card, a boy builds a conical hat. You know what a conical hat is, right? It's the hat that we use in birthdays, this kind of stuff. And places this hat with the base resting on a table. So you put the hat on the table. How far is the beak of the hat from the table? So what is the distance between the point of the hat to the table? So let's work. So first of all, we need to remember what is a semicircle. A semicircle is the half of a circle. They informed us that we have a semicircle of radius 20. So I draw here a semicircle. You bear with me because I draw it manually with no help of compass or anything. Semicircle, half of a circle of radius 20. 20 here and 20 here. And I call it RSC, radius of the semicircle, okay? If we take the semicircle, imagine a boy cutting the semicircle to the parts that I'm showing here with the pointer, okay? And transform it into a hat. So it's similar to getting a paper, okay? I'm doing something like this, okay? It's not perfect because I'm taking a rectangle paper, but if we do it with the same circle, and I encourage you to do that, cut the same circle and do that, you see that's going to form a cone. If you unite this part here with this part here. So comparing the same circle with the cone, this part here is going to be this part here of the cone, which we call its length height, okay? This part here, okay, so the border of the same circle, excluding this part, okay, it's going to be the base of the cone, the circle at the base of the cone, okay? So what was requested from us was the distance between the beak, and the table. If we translate into mathematical words, it's going to be the distance between from the apex, which is this point here, okay, and the base of the cone, okay, which is the center of the cone here. If you look at this cone, it's very easily to see that the h, which is the height of the cone, which is the variable that we're trying to find. The g, which is the length height, and the rc, that is the radius of the cone. The three of them form a rectangular triangle, okay, of height h, this length, hypotenuse is g, and rc, okay? If we have g and we have rc, we'll be able to calculate the height, which is our variable of interest. The g we already have. I already told you that the g is going to be exactly this radius of the semicircle. So g equals 20. We don't know rc. We need to calculate rc in order to reach to the height h. Although we do not know RC, we do know that the perimeter of the base of the cone is going to be the length of this arc here on the semicircle. So what is the formula that gives us the perimeter of a circle? 2 pi r. So 2 pi r. In this case, r is the radius of the cone, equals the length of this arc. It's very easy to see that the length of this arc is the half of the full perimeter if the circle was complete. So what I'm going to do is I'm going to calculate the full perimeter, which is 2 pi r sc, and divide it by 2. I'm going to have the length of this arc, which is the half of the length of the full circle. So 2 pi r sc, the full length, divided by 2. I can cut this 2 pi with this 2 pi, and then it becomes RC equals RSC divided by 2. RC equals RSC divided by 2. Then we get to RC equals, what is the value of RSC? 20. Okay? 20. 20 divided by 2 equals 10. So now we have RC, which is 10, G, which is 20, and we can use the Pythagoras theorem to calculate the height of this triangle, which is, in essence, the height of the cone. So G squared equals H squared plus RC squared. Our variable of interest is the H, so I'm going to pass this RC to the other side of the equation and change the sides. It's going to come H squared equals G squared minus RC squared. Substituting the variables by their values, it comes H squared equals G equals 20, 20 squared, minus RC equals 10, 10 squared. So H squared is going to be 20 squared minus 10 squared. From this to this line to this line, I'm taking 2 steps. I'm already calculating these powers. So 20 squared equals 400, 10 squared equals 100. And this power here, I'm going to transfer its effect, okay, to the other side. If we have a power of 2 in one side, it becomes square root in the other side. So we have H equals square root of 400 minus 100, 300. 300 equals 3 times 100. So we can, this 100, we have the exact square root of 100. It's 10. So we can put 10 outside of the square root sign. Okay? So it becomes 10 square root of 3 centimeters. This is the final value, the value of the height of the cone. Okay? Thank you very much once again. Don't forget to subscribe, give your like, and put the comments, if you feel so, and about what you thought about the video and next ideas for future videos. Okay? See ya.